Welcome back. In the last episode, we explored how global pressure systems affect climate and seasonal weather. Today, we zoom into something much closer to your cockpit: altimetry. Understanding how pressure affects your altitude readings is critical to flight safety, navigation, and terrain separation. Let's start with the basics. An altimeter is a barometric instrument. It measures atmospheric pressure and converts it into an altitude reading. Since pressure decreases with height, the altimeter shows how high you are based on the pressure around the aircraft. Altimeters are calibrated to the International Standard Atmosphere, or ISA. That assumes sea level pressure is 1013.25 HPA, and temperature at sea level is 15 degrees Celsius, with a lapse rate of 2 degrees Celsius per 1,000 feet. But real conditions rarely match that. That's where pressure settings come in. Pilots adjust the altimeter with a setting like QNH, QFE, or standard to make sure it reads correctly. Let's look at each one and when to use it. QNH is the pressure at mean sea level, corrected to station level. When set, your altimeter shows elevation above sea level. This is the most commonly used setting, especially below transition level, and is essential for obstacle clearance. QFE is the pressure at the airfield surface. When set, the altimeter reads 0 on the ground. This is useful for circuits or training flights in local traffic patterns, but less common in international operations. The standard pressure setting, 1013.25 HPA, or 29.92 in Hg, is used above the transition altitude. It standardizes all aircraft to flight levels like FL 100 or FL 350 for safe vertical separation, regardless of local surface pressure. Let's break that down. Below the transition altitude, you fly using QNH, your true altitude. Above it, you switch to standard and fly flight levels. This allows ATC to separate traffic efficiently at cruising altitudes. For example, two aircraft flying at FL 350 and FL 360 are 1,000 feet apart, no matter where they are in the world. This only works if everyone uses the same standard pressure. That's why switching settings at the correct time is so important. So, what happens if you forget to reset your altimeter? Flying from low pressure to high pressure without adjusting will cause the altimeter to underread you're higher than it shows. The memory phrase is, low to high, plenty of sky. And the opposite. High to low, look out below. If you forget to lower your setting when flying into a lower pressure area, your altimeter will overread you'll be lower than indicated. That could put you dangerously close to terrain or obstacles. Temperature also plays a role. In cold air, pressure levels are closer together, so altimeters overread. That means your true altitude is lower than indicated. In extremely cold climates, corrections are required, especially on approach. That's why ECARO recommends cold temperature corrections when the temperature is significantly below standard. Approach charts may include tables or notes to apply these adjustments. Safety depends on it, especially in mountainous areas. Let's talk about pressure altitude. It's the altitude shown when the altimeter is set to standard pressure 1013.25 HPA. It's used for flight level assignments, aircraft performance calculations, and density altitude formulas. Speaking of which, density altitude is pressure altitude corrected for non-standard temperature. It tells you how the aircraft will perform. High density altitude equals less engine power, less lift, longer takeoff. We covered that in our density episode. Another key term, true altitude. This is your actual height above sea level, what you really care about when avoiding terrain. It equals indicated altitude only when the pressure setting and temperature match standard. Otherwise, it can vary. Then there's absolute altitude, your height above the ground, not sea level. This is what terrain awareness systems care about. It's important in mountainous terrain and when flying VFR at low level. Let's put it all together. Indicated altitude equals what the altimeter shows. Pressure altitude equals indicated altitude with 1013.25 set. Density altitude equals pressure altitude corrected for temperature. True altitude equals actual height above sea level. Absolute altitude equals height above the ground. Let's look at a real-world scenario. You're descending into an airport with rapidly falling pressure. If you don't adjust your QNH setting, your indicated altitude will be too high and you'll descend below the glide path. That's a serious risk. That's why ATIS, METARs, and controllers provide QNH updates. Always set it as early as possible. Cross-check the field elevation against your altimeter on approach. If it doesn't match, something's wrong and it could be dangerous. In mountainous regions, always apply cold temperature corrections, and never trust the altimeter blindly. Use GPS altitude as a secondary reference. It's not perfect, but it can help identify large discrepancies before they become critical. Also be aware of transition levels, especially in busy airspace. ATC will give you the current transition level based on QNH. It's not always the same as the transition altitude published on charts. Always confirm when changing between altitudes and flight levels. Let's do a quick recap. Altimeters measure pressure, not actual height. Settings like QNH and standard pressure help align them with reality. Failing to update your setting can result in dangerous altitude errors. Temperature and pressure both affect your true altitude. Always cross-check, especially near terrain or in cold weather. In our next episode, we'll continue with altimetry, part 2. We'll cover RVSM airspace, vertical separation minima, barometric errors, and how technology like GNSS is changing the way altitude is measured and managed. See you in Meteorology number 10, Altimetry, part 2.